grade 7. For today, our topic is converting measurements and solving problems involving conversion. And this was based on Mathematics 7, Quarter 2, Module number 2.
This is from LRMDS Bulacan. Thank you and congratulations to the development team of this module. Credits to the author, language reviewer, content editor, illustrator, and layout artist of this module.
Hi grade 7, are you ready? Let's learn, have fun, because mathematics is fun.
What I need to know.
This module provides varied activities that will help you learn about converting of measurements and solving problems involving
Conversion of measurements.
It will also help you to follow a few simple steps to solve the different activities. It includes the following subtopics. Number 1, converting measures of length. Number 2, converting measures of mass and weight and volume. And number 3, converting measures of time and temperature. At the end of this module, you are expected to convert measurements from one unit to another, convert measurements from metric to English system and vice versa. And number 3, solve problems involving conversion of units of measurements.
What I know. Now turn your module to pages 4 and 5. Let's answer our pretest. Answer the following questions. Write the letter of your answer on the sheet. What's in? Perform the indicated operations on decimals. Let's have example number 1. 12.34 plus 22.68. Now let's get the sum. 4 plus 8 is 12. Then carry 1. Now 1 plus 3 plus 6 is equal to 10. Then again, carry 1. Now 1 plus 2 plus 2 is equal to 5. Then 1 plus 2 is equal to 3. Now, just bring down the decimal point. Now example number 2. 34.5 plus 564.12 plus 0.005. To add 3 addends, all you have to do is to align the decimal point. Now the only number in the thousands place is number 5. Just bring down 5. 2 plus 0 is equal to 2. 5 plus 1 plus 0 is equal to 6. 4 plus 4 plus 0 is equal to 8. 3 plus 6 is 9. Then bring down 5. For the decimal point, just bring down the decimal point. Example number 3. 34.52 minus 12.31. To subtract decimal numbers, all you have to do is to align the decimal point. 2 minus 1 is 1. 5 minus 3 is 2. 4 minus 2 is 2. And 3 minus 1 is 2. Then bring down the decimal point. Example number 4. 67.5 minus 12.38. Again, align the decimal point. In this case, we have to add 0. We need to borrow 1 from 5 and this will become 4. Now 0 will become 10. 10 minus 8 is equal to 4 minus 3 is 1. 7 minus 2 is 5. 6 minus 1 is 5. Then bring down the decimal point. For example number 5, we have multiplication of decimals. 21 times 12.5. In this case, you do not need to align the decimal point. Now let's multiply each term of the multiplier. 5 times 1 is 5. Now 2 times 5 is 10. Now let's proceed to the second term. 2 times 1 is 2. 2 times 2 is 4. Now let's proceed to the last term. 1 times 1 is 1. 1 times 2 is 2. Now let's add all the products. Bring down 5. 0 plus 2 is 2. 1 plus 4 plus 1 is 6. And bring down 2. For the decimal point, add the decimal point in the factors. We only have 1, so we need to move the decimal point of the product 1 time to the left. Example number 6. 33.4 times 12.9. Let's multiply the two factors. First, multiply 9 times 4. Our product is 36. Put 3 at the top as carry 3. Now let's proceed to 9 times 3, which is 27, plus 3, that is 30. Then we have carry 3. 9 times 3 is 27, plus 3, that is 30. Let's proceed to second term. 2 times 4, that is 8. 3 times 2 is 6. And 3 times 2 is 6. For the last term, we have 1 times 4 is 4. 1 times 3 is 3. And lastly, 1 times 3 is 3. Now get the sum of the product. First, we have to bring down 6. 0 plus 8 is 8. 0 plus 6 plus 4 is 10. Then carry 1. 1 plus 3 plus 6 plus 3 is 13. Then carry 1. 1 plus 3 is equal to 4. Now, let's count the total number of decimal places in the factor. We have here 1 and another 1. We have 2 decimal places. We need to move the decimal point 2 places to the left. For our 7th example, we have division of decimal. 25 divided by 2.5. In this given example, our divisor is a decimal number, so we have to change it into whole number. We move the decimal point 1 time to the right. Now 2.5 will become 25. For our dividend, we also need to move the decimal point to the right. Now this will become 250. Now let's proceed to division of whole numbers. 250 divided by 25. The answer is 1. Then we have to multiply 1 and 25. Our product is 25. Now let's subtract 25 by 25. We have 0. For the next step, we have to bring down 0. Then proceed again to the first step, which is division. 0 divided by 25. We have 0. 0 times 25 is 0. 0 minus 0 is 0. So our final answer is 10. For our last example, we have 10.5 divided by 5. In this example, our divisor is a whole number. If our dividend has a decimal, simply rewrite the decimal point of the quotient. Now let's divide 10 by 5. The quotient is 2. Then let's multiply 2 and 5. The product is 10. 10 minus 10 is equal to 0. Then we have to bring down 5. Now let's divide 5 by 5. The quotient is 1. 1 multiplied by 5 is equal to 5. 5 minus 5 is equal to 0. So our final answer is 2.1. What's new? Now turn your module to page 5. Search for the words that you think you may encounter in this module. Let's try to find some words. Can you find some words? For our first word, we have lengths. Then we have capacity. Next is English system. Then we have weight. We also have mass. We have their volume. There is also time. Another is metric system. There is also temperature. And lastly, we have conversion. What is it?
The metric system of measurement. The metric system of measurement is a standard unit adopted in the Philippines. Its conversion factors are based on the decimal system. The base unit for length in this system is meter, and units longer or shorter would be achieved by adding prefixes to the base unit.
Metric system of measurement. Here are the common prefixes used in the metric system. For the first prefix, we have tera. The symbol is T and the factor is multiplied by trillion. Next one is giga. The symbol is G and multiplied by billion. Next is mega. The symbol is M and the factor is multiplied by 1 million. Next is kilo. The symbol is K multiplied by 1000. Next is hector. The symbol is H and the factor is multiplied by 100. Next is deca with the symbol DA. The factor is multiplied by 10. Next one is deci with the symbol D. The factor is multiplied by 1 over 10. Then we have centi with the symbol C. The factor is multiplied by 1 over 100. Next is milli. The symbol is M. The factor is multiplied by 1 over 1000. Next is micro. That is the symbol and the factor is multiplied by 1 over 1 million. Then lastly, we have nano with the symbol N. The factor is multiplied by 1 over 1 billion. And that is the common prefixes used in the metric system. Now let's proceed to lesson number 1. Converting measures of length. We have the metric system of measurement for length. The metric system of measurement for length. Below is the conversion table of metric system for length. This conversion factor may be used to convert from big to small units or vice versa. Now let's analyze the conversion table. For every 1 kilometer, we have 1,000 meter. For every 1 hectometer, we have 100 meter. 1 decameter is equal to 10 meters. And of course, meter is our basic unit. We have 1 decimeter is equivalent to 1 over 10 meter, or 1 meter is equal to 10 decimeter. We also have 1 centimeter is equivalent to 1 over 100 meter, or 1 meter is equivalent to 100 centimeter. Lastly, we have 1 millimeter is equivalent to 1 over 1000 meter, or 1 meter is equivalent to 1000 millimeter.
In converting one unit to another, make sure that the original unit is in the denominator of the conversion factor. Then, apply cancellation to terminate the original unit and to simplify the figure if possible.
Let's have example number 1. Convert 4 kilometer to meter. We have 4 kilometers multiplied by the factors 1000 meter over 1 kilometer. First, we can cancel out the common factor, which is kilometer. Then, we can multiply 4 by 1000 meters. Our final answer is 1000 meters. Now we have example number 2. Let's convert 10 millimeters to meter. We have 10 millimeters multiplied by the factors 1 meter over 1000 millimeter. We can cancel out the common factor, which is millimeter. Then we will multiply 10 by 1 meter over 1000. We have 10 meters over 1000. Reducing it to lowest term, we have 1 meter over 100. So our final answer is 0.01 meter.
In some case, where there is no direct conversion factor between two units, convert the given first to the base unit before converting it to the required unit. Since our base unit for length in the metric system is meter, convert the given measure of length to meter, then to the required unit.
Example number 3. Convert 35 hectometers to decimeter. 35 hectometers multiplied by the factor 100 meters over 1 hectometer. We have no direct conversion between hectometer and decimeter, so we will change first hectometer to meters. Now let's cancel out the common factor, which is hectometer. 35 multiplied by 100 meters is 3,500 meters over 1. Multiplying it to the factors 10 decimeter over 1 meter. Canceling out the common factor, meters, then multiply 3,500 by 10 decimeter. Our final answer is 35,000 decimeter. Example number 4. Convert 5,200 millimeters to decameter. 5,200 millimeters multiplied by the factor 1 meter over 1,000 millimeter. Let's cancel the common factor, millimeters. Then let's multiply 5,200 and 1 meter over 1,000. The answer is 5,200 meters over 1,000. Then multiply it to the factor 1 decameter over 10 meters. Cancel out the common factor, meters. Then multiply 5,200 over 1,000 and 1 decameter over 10. We have 5,200 decameter over 10,000. Reducing this to the lowest term, we have 52 decameter over 100. Or dividing it, we have the value of 0.52 decameter. Lesson number 1. Converting measures of length. Next topic is the English system of measurement for length. The English system measurement for length. Now here is the conversion table. We have the unit of measure, symbol, and the factors. For the first one, we have feet or FT. For every 1 foot, we have 12 inches. Next is yard or YD. For every 1 yard, we have 3 feet, or for every 1 yard, we have 36 inches. Next is mile or MI. For every 1 mile, we have 1,760 yards, or for every 1 mile, we have 5,280 feet. Now let's proceed to English to metric equivalents. 1 inch is equivalent to 2.54 centimeters. Next is 1 foot is equivalent to 30.38 centimeters. Then we have 3.3 feet is equivalent to 1 meter. For 1 yard, we have 0.9 meter. And lastly, 1 mile is equivalent to 1.6 kilometers. Let's try this given example. Convert each measure of length from 1 unit to another. Let's convert 72 inches into feet. 72 inches multiplied by the factor 1 feet over 12 inches. First, let's cancel out the common factor, which is inches. Then multiply 72 and 1 foot over 12. Then we have 72 feet over 12. Reducing it to lowest term, our final answer is 6 feet. For example number 2, we have to convert 39 feet to yards. 39 feet multiplied by the factor 1 yard over 3 feet. Again, cancel out the common factor, which is feet. Multiply 39 by 1 yard over 3. Then we have 39 yards over 3. Reducing it to lowest term, our final answer is 13 yards. Example number 3. Convert 2.5 miles to feet. 2.5 miles multiplied by the factors 5,280 feet over 1 mile. Now let's cancel out mile. 2.5 multiplied by 5,280 feet. Our final answer is 13,200 feet. Example number 4. Let's convert 12 inches to centimeters. 12 inches multiplied by the factors 2.54 centimeters over 1 inches. Now let's cancel out inches. Then multiply 12 by 2.54 centimeters. Our final answer is 30.38 centimeters. Then we have example number 5. Convert 9 feet to meters. 9 feet multiplied by the factors 1 meter over 3.3 feet. Let's cancel out the common factor, feet. Then multiply 9 and 1 meter over 3.3. We have 9 meters over 3.3. Reducing it to lowest term, we have 2.72 meters. Or we have 2.73 meters. From a 60-meter bolt of cloth, how many pieces 25 decimeters long can be cut? After reading and analyzing the problem, Make sure to express the given measurements in terms of the required unit. Length of a bolt of cloth is equivalent to 60 meters or 600 decimeters, while the length of the piece of cloth is 25 decimeters. Giving its mathematical phrase, we have 600 divided by 25. So for our solution, 600 divided by 25 is equal to 24. For our final answer, we have 24 pieces of cloth, 25 decimeter long, can be cut from a 60-meter bolt of cloth. Lesson number 2. Converting measures of mass and weight and volume.
Converting measures of mass and weight and volume. The basic unit for mass and weight in the metric system is gram, and the most commonly used metric unit for mass and weight are grams and kilograms. For the volume of liquids, the basic unit in the metric system is liter, while for the base unit for the volume of solids is the cubic meter or this symbol. In some cases, cubic centimeter or cc was also used. On the other hand, the English system has its units for measuring mass and weight and capacity. Pound is the basic unit for mass and weight. The commonly used metric units for volume are cubic feet and cubic inches.
Lesson number 2. Converting measures of mass and weight and volume. The first topic is volume of solids.
Volume of solids. Volume is the amount of space an object contains or holds. The volume of a container is considered to be the capacity of the container. This is measured by the number of cubic units or the amount of fluids it can contain and not the amount of space the container occupies.
Here are the formulas to find the volume of irregular solids. Volume of irregular solids. We have the solid, the volume, and the figure. Figure number 1. Now look closely at these two figures. That is a cube. We need to find the edges of a regular cube. To get the volume, we have to multiply the edge times edge times edge, or simply e to the third power. Our next figure is a rectangular prism. Look closely at the figures. To get the volume, we need to multiply the length, the width, and the height, or simply get the area of the base, then multiply by the height. Next figure is pyramid. To get the volume of the pyramid, multiply the area of the base by 1/3 and by its height, or simply 1/3 length times width times height. Our next figure is cylinder. Look at the figures. To get the volume of a cylinder, we have to multiply pi times twice the radius times height of the cylinder, where pi is always equal to 3.14, or simply volume is equal to pi r squared h. Next figure is cone. Look closely at the figure. To get the volume of a cone, we have to multiply 1/3 by pi times twice the radius times height of the cylinder, or simply volume is equals to 1/3 pi r squared h. Our last figure is sphere. Again, look closely at the figures. To get the volume of a sphere, multiply 4/3 by pi times thrice the radius, or simply volume is equals to 4/3 pi r cubed. Let's try to answer the following examples. We need to find the volume of the following solids. Given is a rectangular prism with measures of 4 centimeters, 10 centimeters, and 7 centimeters. We will use the formula volume is equals to length times width times height. Now let's substitute the given value. 7 centimeters times 4 centimeters times 10 centimeters. Our volume is 280 cubic centimeters. Example number 2. The given solid is a cone that measures 15 meters and 8 meters. Now I will use the formula for cone, which is volume is equals to 1/3 pi r squared h. Now let's substitute the given value. Pi is 3.14, radius is 8 meters, and the height is 15 meters. First step is to double the radius, then multiply all the factors. We have 3014.4 cubic meters over 3. Reducing this to lowest term, our answer is 1004.8 cubic meters. Now let's proceed to example number 3. Given is a cylinder with 10 feet radius and 30 feet height. Now let's use the formula for cylinder. Volume is equal to pi r squared h. Now let's substitute the given value. Pi is 3.14, radius is 10 feet, and the height is 30 feet. First is to double the radius, then multiply all the factors. Our answer is 9,420 cubic feet. Now let's try this given example. Which of the following occupies more space? A ball with a radius of 4 centimeters or a cube with an edge of 60 millimeters? For our solution, express the given measurements in terms of the same unit of measure. The dimension of the ball is 4 centimeters, while the dimension of the cube is 460 millimeters or 6 centimeters. Now get the volume of each solid. First, volume of the ball. We will use the formula for sphere. Volume is equal to 4/3 pi r cubed. Now let's substitute the value for pi and for radius. First, let's cube the radius. Then, multiply the factors. We have 803.84 cubic centimeter over 3. Reducing it to lowest term, our answer is 267.95 cubic centimeters. Now let's proceed to the volume of the cube. We will use the formula for cube. Volume is equal to E cubed. Now let's substitute the edges. 6 centimeters raised to the third power. 6 times 6 times 6 is equal to 216 cubic centimeters. So for our final answer, the ball with a radius of 4 centimeters occupies more space than the cube with an edge of 60 millimeters. Lesson number 2. Converting measures of mass and weight and volume. For our second topic, we have volume of liquids and capacity. Volume of liquids and capacity. Now look at this conversion table. Here are the conversion factors for volume and capacity. We have here the metric system, metric to English conversion, and English system. 1 cubic meters is equivalent to 1 billion cubic centimeters. 1 cubic feet is equivalent to 1,728 cubic inches. 1 cubic inches is equivalent to 16.4 cubic centimeters. 1 cubic meter is equivalent to 35.3 cubic feet. Now for metric to English conversion, we have 1 teaspoon is equivalent to 5 ml. 1 tablespoon is equivalent to 15 ml. 1 fluid ounce is equivalent to 30 ml. 1 cup is equivalent to 140 ml. 1 pint is equivalent to 470 ml. And 1 quart is equivalent to 950 ml. We also have 1 liter is equivalent to 1 cubic decimeter. 1 ml is equivalent to 1 cubic centimeters. 1,000 liter is equivalent to 1 cubic meters. Now let's proceed to English system. 1 gallon is equivalent to 3.79 liters. 1 gallon is also equivalent to 4 quarts. 1 quart is equivalent to 2 pints. 1 pint is equivalent to 2 cups. 1 cup is equivalent to 16 tablespoons. 1 tablespoon is equivalent to 1 teaspoon. And 1 cup is equivalent to 16 fluid ounces. Now let's try the following examples. Let's convert 3 gallons to liters. 3 gallons multiplied by the factors 3.8 liters over 1 gallon. Now let's cancel out gallons. Multiply 3 by 3.8 liters. So our final answer is 11.4 liters. Example number 2. Convert 330 ml to tablespoon. 330 ml multiplied by the factors 1 tablespoon over 15 ml. Then let's cancel out ml. Now let's multiply 330 by 1 tablespoon over 15. Our answer is 330 tablespoons over 15. To reduce the lowest term, we have to divide 330 by 15. So our answer is 22 tablespoons. For example number 3, we have to convert 4 quarts to cups. 4 quarts multiplied by the factors 2 pints over 1 quart. Now let's cancel out quarts. 4 multiplied by 2 pints is equal to 2 pints. Now we have to multiply 8 pints by the factor 2 cups over 1 pint. We can cancel out pint. Then multiply 8 by 2 cups. The answer is 16 cups. Now let's try this example. How much water in cubic centimeters can a cubical water tank hold if it has an edge of 3 meters? For method number 1, find the volume of the tank first, then convert it to cubic centimeters. First step, find the volume of the tank. V is equal to E cubed. Substitute the value. We have 3 meters raised to the third power. 3 times 3 times 3, our answer is 27 cubic meters. Then for our step 2, convert cubic meters into cubic centimeters. 27 cubic meters multiplied by the factors 1 million cubic centimeters over 1 cubic meter. Let's cancel out cubic meters. The answer is 27 million cubic centimeters. Now let's try method number 2. Convert the dimension of the tank into centimeters first before computing for the volume. Step 1. Convert 3 meters into centimeters. 3 meter multiplied by the factor 100 centimeter over 1 meter. Then cancel out meter. Multiply 3 times 100 centimeter. Our answer is 300 centimeters. Then step 2. Find the volume of the water tank. Volume is equals to E cubed. Substitute the value. We have 300 centimeters to the third power. 300 times 300 times 300. The answer is 27 million cubic centimeters. So in this given problem, our answer is the cubical water tank can hold 27 million cubic centimeters. Lesson number 2. Converting measures of mass and weight and volume. For topic number 3, mass and weight.
Mass and weight. Mass and weight use the same unit of measure, but they are not exactly the same. Weight is the amount of force or gravitational force acting on an object, while mass is the amount of matter contained in an object.
For our mass and weight, here is the conversion table. 1 kilogram is equivalent to 2.2 pounds. 1 kilogram is also equivalent to 1,000 grams. 1 gram is equivalent to 1,000 milligrams. And 1 pound is equivalent to 16 ounces. We also have 1 metric ton is equivalent to 1,000 kilogram. 1 metric ton is also equivalent to 2,200 pounds. 1 pound is equivalent to 450 grams. And 1 ounce is equivalent to 28 grams. Let's have example number 1. Convert 6 kilogram to gram. 6 kilogram multiplied by the factors 1,000 gram over 1 kilogram. Let's cancel kilogram. 6 kg multiplied by 1,000 gram. Our answer is 6,000 grams. Sample number 2. Convert 110 pounds to kilogram. 100 pounds multiplied by the factors 1 kilogram over 2.2 pounds. Then let's cancel out pounds. 100 multiplied by 1 kilogram over 2.2, we have 110 kilogram over 2.2. Reducing it to lowest term, we have 50 kilograms. Example number 3. Convert 30 ounce to gram. 30 ounces multiplied by the factors 28 grams over 1 ounce. Now, let's cancel out ounce. 30 multiplied by 28 grams, our answer is 840 grams. Now let's try this given example. A featherweight boxer weighs less than 125 pounds. Manny weighs 56 kilograms. Will Manny qualify for the division? Now for our solution, step 1. Convert Manny's weight from kilograms to pounds. 56 kilograms multiplied by the factors 2.2 pounds over 1 kilogram. Let's cancel kilogram. 56 multiplied by 2.2, we have 123.2. Now for step number 2, compare Manny's weight in pounds. Our answer is yes. Manny qualified for the featherweight division. Lesson number 3. Converting measures of time and temperature. For our first topic, we have time. Time. We are familiar with the conversion factors for measures of time, such as 1 century is 100 years. 1 decade is 10 years. 1 year is 365 days. 1 leap year is 366 days. 1 month is 30 days. 1 week is 7 days. 1 day is 24 hours. 1 hour is 60 minutes. And 1 minute is 60 seconds.
These conversion factors are commonly used in our daily lives. However, we also use two types of notation in stating time. Currently, these are two types of notation in stating time. The first one is 12-hour notation or the standard time. The second one is the 24-hour notation or the military time or astronomical time. 12-hour notation or standard time. Standard time make use of AM or ante-meridian and PM or post-meridian to distinguish between the time from 12 midnight to 12 noon and from 12 noon to 12 midnight. This sometimes lead to ambiguity when two suffixes of AM and PM are left out. 24-hour notation, military or astronomical time. Military time prevents this ambiguity by using the 24-hour notation where the counting of the time continues to 24. In this notation, 3 p.m. is expressed as 1500 hours, while 5:30 p.m. is expressed as 70:30 hours. Let's try this given example. 12-hour notation or standard time and 12-hour notation, military or astronomical time. 3 a.m. is equivalent to 300 hours. 2:30 p.m. is equivalent to 14 and 30 hours. 12:15 a.m. is equivalent to 00:15 hours. 12:15 p.m. is equivalent to 12:15 hours. And 9:40 p.m. is equivalent to 21 and 40 hours.
Lesson number 3. Converting measures of time and temperature. Our second topic is speed.
Speed. Speed is the rate of an object's change in position along a line. Average speed is determined by dividing the distance traveled by the time spent to cover the distance. The base international unit for speed is meter per second. The commonly used unit for speed is kilometer per hour. This one or this one. For the metric system, and miles per hour is this one and this one for English system.
Let's have example number 1. A horse runs 200 kilometers in 4 hours. What is the average speed of the horse? For our solution, we have 200 kilometers divided by 4 hours. The answer is 50 kilometers per hour. Now let's have example number 2. An athlete runs 500 meters in 5 minutes. For letter A, find his average speed. For letter B, at this rate, how far can he run in 20 minutes? Now look at our solution. 500 meters over 5 minutes. We can divide 500 by 5. Our answer is 100 meters per minute. 100 meters divided by 1 minute multiplied by 20 minutes. First, we need to cancel out the common factor, which is minutes. 100 meters times 20, we have 2,000 meters. Example number 3. Pope Francis visited the Philippines on January 15, 2015 and went back to Vatican City on January 19, 2015. The papal entourage left Villamor Air Base in Pasay City on board Shepherd 1, a special Philippine Airlines flight, at 10-12 hours. Also in January 19, and arrived in Rome's Ciampino Airport at 14 hours, which is Manila time, on January 20. The distance between Rome and Philippines is 6,459 miles. For the first question, we have, what time in standard time is the plane supposed to arrive in Rome? And for letter B, what is the plane's average speed? Now here is our solution. Departure time from Villamor Air Base is 10-12 hours or 10-12 a.m. The total time traveled is 14 hours. So the arrival time in Ciampino Airport is 12:12 a.m. of January 20. For our second question, which is what is the plane's average speed? Here is our solution. 6,459 miles divided by 14 hours. The answer is 461.36 miles per hour. We can simplify it by 461 miles per hour. Lesson number 3. Converting measures of time and temperature. Our last topic is temperature.
Temperature. Temperature is the measurement of the degree of hotness and coolness of an object or substance. While the commonly used units are Celsius or degree Celsius for the metric system, and Fahrenheit or degree Fahrenheit for the English system. The base or international unit for temperature is the Kelvin. Unlike degree Celsius and Fahrenheit, which are considered degrees, the Kelvin is considered as an absolute unit of measure of temperature and therefore can be worked on algebraically. Here are some conversion factors. If we are looking for degree Celsius, here is the formula. Degree Celsius is equal to 5/9 multiplied by the difference of degree Fahrenheit and 32. If we are looking for degree Fahrenheit, we have degree Fahrenheit is equal to 9/5 multiplied by degree Celsius added by 32. And if we are looking for Kelvin, Kelvin is equal to degree Celsius plus 273.15.
Now let's have example number 1. Convert 80 degrees Celsius to degree Fahrenheit. Here is our formula. Degree Fahrenheit is equal to 9/5 multiply by degrees Celsius plus 32. Then substitute 80 to degrees Celsius. We will change the value of degrees Celsius. Multiply 9 and 80. We have 720 over 5 plus 32. Divide 720 by 5. We have 144 plus 32. Now add 144 and 32. Our final answer is 176 degree Fahrenheit. Example number 2. Convert 221 degree Fahrenheit to degree Celsius. This will be our formula. Degrees Celsius is equal to 5 over 9 multiplied by the difference of degree Fahrenheit and 32. First, substitute 221 to degree Fahrenheit. This will be our format. Subtract 32 from 221. The answer is 189. Multiply 5 and 189. The answer is 945 over 9. Lastly, divide 945 by 9. Our answer is 105 degrees Celsius. Example number 3. Convert 37 degrees Celsius to Kelvin. Our formula is Kelvin is equal to degrees Celsius plus 273.15. Substitute 37 to degrees Celsius. We have 37 plus 273.15. Now, add 37 and 273.15. Our answer is 310.15 Kelvin.
Are you ready to answer your module? Good luck!
What's more? Independent activity number 1. Turn your module to page 16. Identify the equivalent measures from the box below and write each pair on your answer sheets. Independent assessment number 1. Turn your module to page 16. Convert the given measures from one unit to another. Write your answers on your answer sheet. Express your answers up to 3 decimal places, if not whole numbers. Independent activity number 2. Turn your module to page 17. Match its unit measures in column A with its equivalent measures in column B. Write the letter of the correct answer in your answer sheet. Metric to English equivalence. Independent assessment number 2. Turn your module to pages 17 and 18. Convert the given measures from one unit to another. Show your solutions and write it in your answer sheets. Express your answers up to 3 decimal places, if not whole number. And for part 2, you have to complete the table. Independent activity number 3. Turn your module to page 18. Analyze and solve the following problems. Show your solutions and box the final answer with the correct label. Independent assessment number 3. Turn your module to pages 18 and 19. Analyze and solve the following problems. Show your solutions and box the final answer. What I have learned. Turn your module to page 19. Fill in the blanks with the correct words to complete the thought of each sentence. What I can do. Turn your module to page 20. Analyze the following situations. Answer the question and justify your answers. Assessment. Now turn your module to pages 21 and 22. Let's answer the post-test. Answer the following questions. Write the letter of your answer on the answer sheet. Additional activity. Turn your module to page 22. Convert the following measures from one unit to another. Show your solution and box the final answer. Express your answers up to 3 decimal places, if not whole number. References.
It's time for you to answer your module. Thanks for watching. Bye!